Once upon a time, 4 children were told to construct a machine, but not just any machine, a mechanical music maker that could play music for 10 to 60 seconds. It had also to be 50% mechanical, involving more than just electronics. It had to fit in a 3 by 3 by 3 foot box. This machine was to be judged on originality, construction quality, and musical quality. But this machine had to be constructed under the price of $40.
The engineering design cycle involves 5 steps. These are ask, imagine, plan, create, and improve. Asking involves defining the problems and constraints associated with an engineer's design. Imagine involves brainstorming the ideas, choosing the best one, and coming up with anything that could go wrong with each idea. Planning involves drawing a diagram and getting together the needed materials to make the project. Creating is the simple act of making your design, you follow your plan and test it out. And improving is after testing out, defining what are the problems and thinking of ways that you can fix it, and rebuilding, and the cycle continues. In this project, the ask step was not very intensive because the constraints were defined for us. These were a $40 budget, the project had to fit within a 3-foot cube, and the project had to be 50% mechanical. A problem that we were thinking about facing was to use traditional music box with the cylinder or contribute. During the Imagine stage, our team came up with several ideas. Our discarded ideas were first to make a simple music box with a cylinder and xylophone or metal picks, and or a music cylinder that triggers mallets to hit pipes. We didn't do these things because we wanted our project to be able to play any song that was transcribed into music and to make our own idea. Another discarded idea was to make a self-playing clarinet. This was a cool idea, but we couldn't think of a way to execute it. So our final project idea, proposal, was to poke holes in paper that correspond to notes, and light would travel through these holes and trigger corresponding motors to pull a pipe into a brick. Our project plan is described by these 2 pictures. The one on the left details our proposed plan at our earliest stage, and the one on the right depicts the materials that we'd gathered prior to building.
What you doing? Being domestic.
To improve our music maker in the future, we'd like to use light and proper photocells as we'd planned initially. This would eliminate the problem of the wires coming out of line and not hitting each other. We could also keep wires on the same side and use something to press it down instead. Another improvement to the project would be to decrease its size and limit pipe movement so that transport is less cumbersome, and that would just make the project more desirable and something people would like to have in their homes as a decoration or something fun.
Oh, rip. Wish. There we go. Yeah, we're off our A game since the judging. There we go, yeah. The judging one played like 7 to 8 notes, and I was proud of that.
Throughout the construction process, we encountered many design challenges, the first of which was finding a way to effectively strike the pipes. Our first idea was to use mallets to hit the pipes at their nodes in order to create the best sound. However, this idea had many issues, including how the mallets would be drawn back and released each time a note was to be played. The next problem we encountered was finding the best method to read the music. Originally, we planned to use photocells to detect the light that would shine through the holes in the paper as they passed over. Unfortunately, this idea did not work because the photocells that we had bought had too high resistances to work in conjunction with our motors. Next, we planned to use wires on both the top and bottom of the holes for note detection, but this proved to be too hard to implement and was not very accurate. Our final solution was to put copper wire in the paper's holes to improve the note detection. The last major problem we encountered was determining the method that we would use to feed the sheet of paper through the note reader. Our initial idea for this was to have 2 rods on either side of the mechanism and have a crank at one end which would use friction to pull the paper through. However, this idea would have been inaccurate and hard to construct. Another idea we had was to attach the paper to a rod on either side of the mechanism and crank the paper through. This would have worked well, but would also have severely limited the ease at which we could have adjusted the note reader. The idea that we ended up implementing was to simply just attach the paper to the rod only on one side of the mechanism and have the other one dangling free. This was still fairly accurate and allowed us to continue modifying the note reader as we needed to.
When the day of Fed arrived, the children carried their machine into McKimmon Center. Anticipation was high. People applauded them for the creativity of their design. But alas, when the judges came, only 40% of the notes played. The machine was manually playable, but this was not enough. The Dumbledinger ended in 7th out of 11th place.
If we were to do our project over again, we would go back to our original idea of using LEDs and the proper photocells to relay music. In that idea, we wouldn't have had a problem with the wires not touching, and it probably would have eliminated a lot of our challenges that we faced. Another thing that we would do in the future is we would keep wires on the same side and just have something to press them down together so that we wouldn't have the problem of them not touching. A third thing that we could improve is decreasing the size, because overall it was just too big and too much of a nuisance to be transported back and forth from the places we needed it to. And a fourth thing would be to limit the pipe movement, because once they were pulled and made this sound, they would bounce and hit each other and create more sound that was unnecessary and unneeded. And lastly, we would just need better transport, because again, with the size and everything, it was a struggle for us to get it where it needed to be.
Dear future freshmen, upon beginning your Fed project, always be open to new ideas for creative breakthroughs. Analyze all possible flaws with each part of your design so as to avoid too many difficulties when constructing it. If you want to make a breakthrough and take big risks, one must always anticipate that it might not work. It's important to balance this with the time and resources you have. That's just a natural consequence of the engineering design cycle and of taking risks in general. Failure, my friends, is a necessary part of engineering in real-world applications.